The tangent function is going to look a bit different than cosine and sine. The first thing that you'll notice is that there's going to be these vertical asymptotes periodically. It will repeat just like the sine and the cosine, but it's going to look different. We're going to have an asymptote at 90 degrees. And you might recall from our rational functions that the asymptotes are actually these imaginary lines that the graph approaches but never crosses. Then when we start to put the graph in, it starts at the origin just like the sine function, and it approaches the asymptote on each side. So it's approaching the asymptote here and here. Comes up from here, crosses at 360, and approaches the next asymptote. That's what our tangent function looks like. These go up forever and down forever, which is why our range is going to actually be all real numbers this time. But the domain is not all real numbers, because as you can see, we have graph right here, but then it stops at the asymptote, and then we have graph, and then it stops at the asymptote, and so on. So we have to account for these breaks in the domain. This is one way to write it, to say that the domain of theta, where theta does not equal 90 degrees, and every 180 degrees after that. That's one option. It doesn't have an amplitude because it doesn't go up and then back down. It just goes up forever and down forever. So there is no amplitude. And then the period where it repeats is going to be every 180 degrees. Okay, let's take a look at graphing some of these. Again, the period is going to follow the same formula that we used for sine and cosine, except it's a little bit different. Now, instead of being 360 divided by the absolute value of b, it's 180 degrees divided by the absolute value of b. And then we also want to find some equations for the asymptotes on the tangent function. The asymptote formula that we're going to use is 180 degrees divided by twice the absolute value of b. That tells us where to draw in the asymptotes. So let's talk about the period of this example here. The period I'm going to scroll up here to our function up at the top, right here. This is where we're getting our information from. B is still the coefficient of theta. So as we scroll down here, the coefficient of theta is just 1. So our period using the formula is 180 degrees divided by the absolute value of 1, which is 180 degrees. If we want to find the asymptotes, we would take 180 degrees divided by twice the absolute value of b, which gives us 90 degrees. So flipping over to Desmos, we're going to type this in, 1/2 tangent of theta. And again, things are not going to be reported in degrees as we wish, but they are actually reported in radians. We know that pi in radians is the same thing as 180 degrees. So this is 180 degrees right here. Can zoom out a little bit. This is 360 degrees. This is 0. So we know that it's going to cross at 0, 180, 360. So let's mark that. 0, 180, 360. And we also know that we have these asymptotes right here at 90 and every 180 degrees after that. So at 270. Now from here we can draw in our tangent function. It almost reminds you of the cube root, or the cubic function rather, as you draw these in.